Hello, everyone, and how are you doing out there? All righty then. This is Dr. Dax. Welcome back to class. We are now entering into week 7 of your 11-week course. And so I hope that everybody out there is doing well, that you've had a great weekend, and everyone is safe and healthy. And right now, I don't know what part of the country you're in, but where I am, there's a lot of storms wreaking havoc in the eastern North Carolina. As a matter of fact, I almost didn't make it to class for this recording because we have an outage and a lot of power is down and some phone lines are affected and my internet is coming and going. And so if we get interrupted here, then we'll reschedule and reconvene. But for right now, fingers crossed, everything's working pretty well. I'm kind of fortunate to be here because my day job, where I work at AT&T, is kind of there's a lot going on because of the storms. And I respond usually to outages in the data centers because tickets that flow through pop in there first just to make sure it's not localized. And we send the tickets out on whichever cables are affected. But I got out of there, I think, just in time, kind of like that meme you might have seen of the little airplane flying away from the explosions in the background. But when I was at the office this evening, power had been lost in that part of the city. It's a little small city in Johnston County, North Carolina, where my main office is that I report to. And the power grid is fairly ancient. So anytime there's a little bit of a storm, the limbs hit the power and, we have flashes and stuff. So we had a power transfer. The generator was running as I calmly drove away from the facility. So we have power, at least for a few days. But usually the power comes back with the local power crews and stuff. And there's a power team that responds to those tickets anyway. So we are good, and we're here. We're here. I'm here, and I appreciate you being here with me. So that's kind of a nice segue into today's talk. We're going to actually be talking about disaster recovery and backups. Now, we've talked a little bit about this topic already, coupling it in with some other ideas. We're going to delve a little bit deeper and go into some good case study material, and we will describe some good best practices. So without further ado, I am going to go ahead and open up our presentation and we will get this show on the road. Before we get too far, though, I want to say that we are looking at a point where you should be looking at deliverable 4 at least, and some of you have turned those in, and it's looking good. And I'm seeing better production on APA formatting and stuff like that. So thank you for listening and applying those lessons and comments. And always look for feedback and commentary in your grades because there are one or two places that some of you are missing because you missed a little bit of the rubric. So read your feedback and understand that you got multiple attempts. You can re-upload your stuff, and there's still there's still 3 weeks left. Or 4 if you count this week. So you're not 10. Yeah, we're cool. We're cool. If you have any questions at all about any of that, shoot me a message. All right. So today, backups and disaster recovery. It's our first lecture of the week, and we're going to dig on in. And let's talk about the objectives. First of all, what I want to do is we're going to be talking about some what I call epic disasters in data center history. And we will talk about disaster recovery, some lessons that were learned from those scenarios. We will describe operational backup and restoral, because that's not the same thing. And we'll talk about backups specifically in the NAS environments. And so it's going to be a good one. I always say that, don't always mean it, but I didn't mean it today. It's a good one. So let's talk about some lessons learned from epic disasters in recent history. First one I want to hit is the Vancouver City proper with the power outage. And that's a good one. And I included it because it includes a really good lesson on what I like to call the domino effect. The Vancouver disaster was a major power outage. And as if that wasn't enough, it disabled traffic lights, obviously, because that's part of the power grid, and it halted ATM operation. Multiple websites also experienced downtime. Servers were affected. lots of different industries and businesses were impacted negatively. Now, the reason this one is significant and it warranted inclusion was this. It started with a fire, a circuit fire that led to a near citywide power outage. The fire was not contained quickly enough, and as you would expect, when power was lost, there were backup generators that kicked on automatically. So the data centers infrastructure did their job. When the power was gone, backup generators kicked in, and so far so good. That was putting a band-aid on the wound, but it didn't heal the wound, because here's what happened. When fire departments responded finally to the fires, they employed lots of different groups to come and work in that power grid, and the larger than anticipated number of firemen accessing the water caused the water pressure to go down. And the diminished water pressure caused the backup generator's cooling system to fail, because it shuts off when it gets below a certain threshold of water pressure. So several different things here happened at the same time concurrently that were not anticipated and were not designed for. So that created a real perfect storm of problems. Here's another situation that I included it because this one happened several times in a row within a short amount of time. And in this story, 3 undersea internet cables off of the coast of Dubai in Egypt were affected, and restoral took days. You might not have put a lot of thought into this, but between continents, there are large cables. We call them submarine cables. They're high profile cables, and they're obviously very, very deep and don't generally get any kind of an impact. But near touristy areas where cruise ships tend to drop, there are some problems. Cut cables in this situation hurt the Mideast web traffic, prompting lots of conspiracy theories because of the geographic location and the timing. Several undersea cables being cut are quite common. But the tinfoil hat crowd suspected that the U.S. military or terrorists were behind the snafu. They weren't. What happens is these large cruise ships drop anchor, and the anchors tear into the cables and create havoc because they rip them up. And there's not a situation where the records are very good. So that's going to keep happening until they get a good database of all the locations. Hopefully that's better now. That's been a few years ago, but it happened several times within a year span and was not good. And finally, including this section here, this is more of a general casting a wide net because this happens all the time. Squirrels are a major problem in our telecom network. They get into the main cables, fibers, coaxial, they don't care. Squirrels account for an estimated 17% of data center outages, and that's coming from a study from Level 3 Communications. And working in that industry specifically, I can say I believe it. It's a real problem. It is a real problem. And it doesn't seem to matter whether you're in a suburb or in a major city or a small town. Doesn't matter. These little tree rats are everywhere, and they will chew through anything. Fiber optic lines, power cables, you name it. In Virginia Beach, 10,000 customers were affected because squirrels chewed through high-profile cables. Now, you might be wondering, how can a squirrel chew through 10,000 pairs? Keep this in mind. When we're talking about twisted pairs, traditional telecom cable, you imagine that big black cable full of those multicolored wires, and you'd be right. But a lot of times we also put POTS lines grouped together through digitization on coaxial cable and fiber optic cable. So a lot more customers can be on a much smaller cable. You can put it on C48 or on C192, and it's smaller than a pencil. And thousands of customers will reside on that. And unfortunately, in our grid, we tend to a lot of those cables together just for simplicity, cost savings, and redundancy is difficult to maintain. So, yeah, one or two squirrels can wreak a lot of havoc in a high profile cable. And it can cause damage like this. They get into the sheath in just a matter of minutes, and they can tear up all kinds of stuff. They see here copper lines that are affected, but they can get into a track terminal like this one and really cause damage. They also get into our underground CEV hertz and all kinds of stuff. They're a big nuisance. So much so that a big business out here is dealing with nuisance squirrels through using those falconry. There's a falconry company. That's what I was trying to say. And they literally get paid to come out and release their hawks and clean up the squirrels in a business. So the big case study I want to share with you is NGC's shipyard. This was a big problem years ago, and well, let's just dive into it. Recovering IT in a disaster. So this part is about how to adapt when the business continuity plan and the public infrastructure are inadequate. It created a situation where they had to re-examine the processes for preparing disaster plans and processes for assessing preparedness and response after disaster or a near disaster. So in this hurricane, one of the lessons learned was to prepare the data, prepare for any incoming hurricane with backups. Data backups were sent to Iron Mountain. They're an information management service, and actually AT&T employs them as well. They're a really a strong reputation, good company. And there was a double backup in Dallas. With the servers, powers were turned off, and they were wrapped up in plastic, and a new backup generator in a secure location was installed. And only one extranet maintained, crucial to the Navy and the Department of Defense. And the manpower was protected by just having them leave the area and prepare kind of a preemptive evacuation. And the storm hit and created all kinds of havoc. The NGC's facilities were in the storm's path. Unfortunately, communications failed and extensive damage to the shipyard and nearby communities was noted. The Emergency Command Center at the Dallas office was a newly assembled emergency response team, and they began to pull together the first stages of NGC disaster recovery response as soon as they could. They collected digital images of the damage, and at Mississippi, they lost 1,500 PCs, 200 servers, 300 printers, 600 data input devices, hundreds of two-way radios, and communications closets, routers, switches, fiber optic cables, and wires were affected. And the networks, the LAN, the WAN, and no longer works. In New Orleans, infrastructures were there. AC systems were not working. So servers were on automatic shutdown. And a week after the storm, communications lines were down again due to cars driving over the cables that were down. So first things first, the priority is not about restoring computer systems, but restoring human resources. Unfortunately, most of the 20,000 plus employees were out of contact. Tools that were used to reach everybody were things like press releases, using the media in order to reach the people, corporate websites. It recorded 67,000 hits in the weeks coming after the storm, and there was a toll-free call-in number that was established. And I'll pause right here and let you know that at the telecom that I work at, we actually do this with an app. It's called I'm Okay or something similar to that. And it's built into all of our mobile devices. And even your BYOD, you bring your own device. If you do, you are required to download that app. And anytime there's a major event that affects our facilities, we have to chime in and report that we're okay. That has the effect of, well, it lets HR know that we're accounted for. But secondly, should they need to deploy emergency crews or anybody that's um, capable of handling disaster response, then they're made available. And okay, so another thing they did was they established a payroll workaround through Walmart and Western Union. In restoring the IT infrastructure, the electronic communications were pretty much non-existent due to public communication infrastructure failure. The communication through Blackberries could be used intermittently. There were two-way radios, walkie-talkies, and key members were using satellite phones. Required line of sight access to satellites, so not super convenient. And later on, they could use wireless communications. Now, some companies actually have portable cell towers that they can establish, mobile cell towers that have limited range but are effective in kind of putting a band-aid over this situation temporarily. And certain places have what we call FirstNet, where first responders, police, medical professionals, people in the telecom industry, specifically those that respond, they're first responders to disasters, get priority of the bandwidth. So their service works. So there are some initiatives that have been built since then. And they went into the process of building the new data center that involved hardware acquisition of 1,500 desktops, 200 servers. There had to be constant contact with suppliers, reordering the latest orders, repeating some efforts, and incompatibilities between software and the new hardware environment was an issue in some spots because the process of getting a new piece of equipment generally in computers is a little bit frustrating if you're dealing with old legacy equipment. Compatibility issues can arise because of the newest operating systems are always a little bit different. So there was an inaccessible or difficult time finding system documentation, license keys, server names, address schemes, login IDs, all that stuff, unless it was stored offline on in the cloud or something. So in restoring data and applications, some firms found that their backup data was partially unreadable. For NGC, there were two backups available, the Iron Mountain and the Dallas backups. They lost some data on the desktops or local machines. And 2 weeks after Katrina, they had a new data center and essential systems were up and running. One common mistake is to prepare for disasters specific to their domain. Financial institutions prepare for IT failures. Hospitals prepare for pandemics. Airlines plan for technical failures and sabotage. These are all important, but you shouldn't limit your focus to just industry-specific problems. An alternative approach is to consider a broader spectrum of disaster types, such as a generic disaster. It can be economic in nature, informational, physical, human resource, reputation, psychopathic, or natural disaster. And what you want to do is identify common characteristics of each disaster category, and then from there, construct a plan. You want to provide generic objectives and measurements, guidelines for establishing IT disaster preparedness, emphasize developing an IT continuity plan, identifying and allocating critical resources, and executing a business impact analysis, and maintaining, testing, and training of the plan. And initiate COBIT, control objectives for information and related technology. So that's for operational IT and business manners, and the focus is on the three core elements of IT governance. Is it an asset, IT-related risk, and IT control structures? In the IT infrastructure library, the focus here is on improving the efficiency and effectiveness of IT services delivered to customers within the enterprise and the de facto standard for IT service management. So let's take a look here at a comparison between COVID and ITIL. We've talked about the ITIL. Um, the description is here for the COVID is open standard that integrates established frameworks. The ITIL is the de facto standard based on best practices from the industry. The focus with COVID is basically on IT governance and control. In the ITIL, the IT service management throughout the organization with an emphasis on the efficiency and effectiveness. So after Katrina, there were some hard lessons that were learned. For one thing, it's important to keep data and data centers out of harm's way when possible. Second, don't assume that the public infrastructure will be available because chances are it won't. Prepare for the worst. Plan for civil unrest. Fourth, assume that some people will simply not be available. And fifth, leverage your suppliers as critical team members. Six, and this casts a broad umbrella, but expect the unexpected. And be prepared. Build a crisis portfolio based on history, lessons learned, and best practices in your industry. Establish a strong leadership position. You want to build a team and ensure that everyone knows who is responsible for what. Excuse me. Ninth, employ decision makers on the team. And 10, exploit fresh start opportunities. So in building the IT disaster recovery plan, or the DR plan, we turn to the National Institute for Standards and Technology, or the NIST, and the goal of the disaster recovery plan is to minimize any negative impacts to company operations by identifying critical IT systems and networks, prioritize their recovery time objective, and delineate the steps needed to restart, reconfigure, and recover them. In the IT disaster recovery process, we're starting by performing a risk assessment, taking a look at the location of the facility, the employees, and the end users within reach. Identify potential threats, whether they're natural disaster, economic, performance related, anything, and determine the important infrastructure elements. From there, you start to form the disaster recovery plan. You begin by developing a contingency plan with a policy statement, a formal policy that provides the authority and guidance necessary to develop an effective contingency plan. From there, you conduct the business impact analysis, the BIA. The business impact analysis helps to identify and prioritize critical IT systems and components. Third, identify preventive controls. These are measures that reduce the effects of system disruptions and can increase system availability and reduce the contingency lifecycle costs. Remember that certain things are inevitable, but by being prepared and establishing preventive controls, you can mitigate and minimize the effects. And fourth, develop recovery strategies. Thorough recovery strategies will ensure that the system can be recovered quickly and effectively following a disruption. Fifth, develop an IT contingency plan. The contingency plan should contain detailed guidance and procedures for restoring damaged system. Next is plan testing, training, and exercising. Testing the plan identifies planning gaps, whereas training prepares recovery personnel for plan activation. Both activities will improve the plan effectiveness and overall agency preparedness. Seventh is plan maintenance. The plan should be a living document that is updated regularly to remain current with the system enhancements. It is not a one and done process for sure. Important considerations to keep in mind is, first of all, senior management support. You want to ensure that everyone is on the same page and that you have buy-in with everybody. Take the IT DR planning process seriously. You need the right information, and that information should be current and accurate. Ensure that there's an establishment of the availability of standards. The IT disaster recovery plans are NIST SP 800-34 and the ISO IEC 24762. And keep it simple. Review the results with business units, and above all, be flexible. Don't establish the thought process that we're going to do it this way because we've always done it this way. Things change, business changes, the needs of the public change, and so it's important to be able to adjust the plan as needed. So reviewing the disaster recovery plan, information technology statement of intent should be established. This sets the stage and the direction of the plan. That's different from the policy statement. The policy statement is an approved statement of the policy that regards the provision of disaster recovery services. The objectives are the main goals of the plan. They are listed out, and key personnel contact information is posted for everybody to see. It's important to have key contact data near the front of the plan. It's the information most likely to be used right away and should be easy to locate. And the disaster recovery plan should be near the front of the facility or somewhere that people will get to it and spot it quickly. Plan the overview, such as updates, and with emergency response, describe what needs to be done immediately following the onset of an incident. And establish the disaster recovery team. Everyone should know who the members are, and the contact information should be available. Emergency alert, escalation, and DRP activation. The steps should take through the early phase of the incident and leading to the activation of the disaster recovery plan. It should be clear, simple, easy to follow, and be prepared for media, insurance, financial, and legal issues. And here I've just included a chart. I'm not going to read it all to you, but it's there for your use. You'll have these notes with a description, the likelihood and impact, detection, how it was happening, and immediate action, later action, effect on users, and a mitigation and contingency. So these are all in place, and it's all documented there for you. Things like data loss, level of impact, machine failures, level of impact, detection, immediate actions, and later actions. These are all general statements that we can use to kind of form the disaster recovery plan. And before we get too much farther, let's take a look at some classic common mistakes. One thing is in the people. People make mistakes. We're not perfect, especially in a high stress situation. It's easy to see someone overlooking some important information. Process. There are often mistakes in the process just because of the stress and sometimes a lack of communication. Excuse me. Mistakes occur with the product. Maybe it's not up to speed. The technology. Classic mistakes with people. There could be an undermined motivation. Individual capabilities of the team members could be misrepresented. There might be a failure to take action to deal with a problem employee, and adding people to a late project. Process mistakes include wasting time on the fuzzy front end approval and budgeting, and aggressively scheduling later. Scheduling and planning should take place early. And there's a human tendency to underestimate the product. Overly optimistic schedules. Insufficient risk management is a problem. Lack of sponsorship. Changes in stakeholder commitment. And scope creep. Contractor failure. Additionally, risks from outsourcing and offshoring. QA interfaces, unstable requirements, these can all contribute to process issues. Product mistakes include things like requirements like gold plating. Is it really necessary? Things like unnecessary product size, characteristics, developer gold plating. That's where developers try out new technology and features. Don't wait until a stressful outage to try something new. And feature creep, a plus or minus 25% change in requirements over the lifetime. Technology mistakes include the silver bullet syndrome. That means that we expect new technology to solve all of our problems. Remember, a new piece of technology isn't the end result. It is a tool to be used to solve our problems. It's a means to an end. Another technology mistake is overestimating the savings of new tools and methods. That kind of goes in with the silver bullet syndrome. Maybe we didn't account for a learning curve or unknown problems, compatibility issues, switching tools in the middle of a project. Not that that's ever happened. So the findings from an empirical study of 99 projects included this. Finding one, that the issues were 43% people, 45% process, 8% product, 4% technology. With scope creep, that was surprisingly not a top 10, although a fourth of the projects faced scope creep, and managers should watch out for it. The top 3 mistakes found in half of the projects should have focused more on estimation, scheduling, stakeholder management, and risk management. And here we've got a chart with lined up common mistakes and best practices to answer them. And I'm not reading that all to you, just this is for you. I'll give you a couple of quick examples. One common mistake, efficient planning. And the best practice to handle that is having a good estimate convergence graph, a comprehensive project charter, project management offices and control, and a solid work breakdown structure. And you guys ought to be very familiar with that. So that's about it for now. I hope that this has been a good lesson. Some of it is a review, things we've talked about before. Some of it went into a little bit more detail. If you guys have any questions or need anything, you've got my contact information there. I'm at dax.bradley@rasmussen.edu, or you can call or text me 252-458-7176, and I'll be more than happy to work with you. So if you guys need anything, give me a shout, and we'll be back in 2 days on Thursday for your second class. I look forward to it. You guys take care. Keep those deliverables coming in, and stay safe and healthy out there. Dr. Dax out.